Have you ever wanted to live in a day and age where Dr. Robertson was a little kid and black and white images were the only type of images around? Well, now you can with DeOldify. DeOldify is a software powered by artificial intelligence that transforms black and white images into colored miracles. Let's see a couple examples. Migrant Mother, Red Bird, and Mr. and Mrs. Lemuel Smith and their children. You may be wondering, how the heck does this happen? Well, Mark has the answers. Take it away, Mark.
So, DeOldify uses a deep learning neural network, which is a neural network with a lot of layers as opposed to neural networks that have just one layer. The way you can think about it is when you're a baby, your brain is a lot simpler, and when you try to speak, you can only produce random noises because you've not learned language yet. But as you grow up and your brain becomes more complex, then you're able to fluently speak the language of your family because you have learned language. And DeOldify specifically uses what is known as GAN, which John Marshall will now explain.
So GAN stands for Generative Adversarial Network. It's composed of two different models, the generator model and the discriminator model. The generator model is what actually creates the color photos from the black and white images. The discriminator model uses labeled training data, that's the supervised learning part of the algorithm, and it also takes in the colored images produced from the generator model, and it determines whether or not the image it receives is fake or real. So they learn together until the generator model fools the discriminator model about 100% of the time, such that the discriminator model just is randomly guessing whether the image it's given is true or false. And then at that point, we get rid of the discriminator model and we use the generator model to create our photos. But this wasn't quite good enough, and so the creator created a new algorithm.
This algorithm is called NoGAN, which, as John Marshall mentioned, was a modification on the original algorithm. So what's different on this algorithm is that the discriminator model and the generator model trained separately. The generator model is trained with feature loss, and the discriminator model is just trained in general. And after these two models are pre-trained, they both go through the normal GAN training process.
So here we see the difference in performance for videos between the GAN and no GAN. In the GAN, we see a bunch of discoloration on the jacket. There's a bunch of red splotches, and obviously this is not correct. Here, no GAN is much more consistent with videos, and this example is just representative of its overall performance.
And then there are possible mistakes that can occur with just images alone, such as in the migrant mother image, the child on the left has a blue shoulder while the rest of the shirt is red, which means either red or blue is meant to be the main color. And then there's also the problem of historical accuracy, such as in the image building the Golden Gate Bridge. While the colored image shows it as white, we know from documentation that it should actually be red at this time.